Light itself was able to cast a shadow in this bizarre laser experiment. And I know that sounds paradoxical because a shadow, by definition, is the opposite of that. It's blocking light from hitting a surface. So it wouldn't make sense that light can cast a shadow because it's the opposite of a shadow. I haven't said shadow this many times since I played Shadow the Hedgehog on Nintendo GameCube, but I gotta tell you, this article is even spookier than Shadow the Hedgehog. What you're looking at here, I'm gonna go ahead and open this up and zoom way, way, way in. The shadow that we're talking about in this entire experiment is this little line that goes across the top, this little top third, top quarter bar. That is a shadow made out of light, and it's mind-blowing that you can even observe it with the naked eye and not just some complicated apparatus in a physics department somewhere. So let's try to explain what in the world is going on here. So to create this shadow, the team shined a high-powered green laser through a cone made of ruby, which you can see down here, that was then lit up on one side by a blue laser so that the green light ends up blocking some of the blue light, projecting it out onto a screen. And as you can see in the diagram here, we have the ruby that will change the colors. We have the illumination laser going in this way. I believe that is the blue one here on the testing apparatus on the right. And then we have, interestingly, this is the hardest part to see, so I'm going to zoom in on this. And these little ellipses here are just points of contact where the green laser hits the crystal to give you an idea of a sense of scale, because we're kind of doing this on 3D. But it's a little slit of light, and you can see that this green light going through the ruby, interacting with the blue light, is actually creating this little slit shadow. That is the thickness of the light that's being broadcast to it. As you can see here in this image, which I should probably zoom back in on again, that is the thickness of the broadcast beam. One of the interesting things about this study is that the laser shadow effect requires a ruby to mediate this blockage, which raises the question of whether the photons in the object laser themselves are blocking the illuminating light, or rather if it's atoms, i.e. excited atoms, in the ruby. Because as we all know, photons have no mass. So something with no mass should not be able to block light, and it should not be able to create a shadow. However, that happened here, so they're wondering if what happened is that as light passes through material, sometimes couples to its atoms, creating quasi-particles called polaritons, which I'm not even going to try to get into today, but the team admits that it's most likely technically these polaritrons, which do have mass and can block light. I mean, if you have mass, you can block light, right? That are casting the shadow. But on the other hand, polaritrons are still half photons, and the shadow couldn't or shouldn't be cast with other photons, because even half photons, like polaritons, don't normally interact with other photons. So I've talked a lot of crazy stuff, just totally rambling here. It is a bizarre experiment, and even the scientists themselves don't understand it fully. I just thought you might find it interesting.